Today's lesson is finding removable discontinuities and vertical asymptotes of rational functions. A removable discontinuity is a point at x on the graph of the function f of x that is undefined. It can be found at x where f of x equals 0 over 0. A vertical asymptote is a line at x that the function f of x will approach infinitely but will never reach. It can be found at x where f of x equals a number over 0.
For example 1, we have to find the vertical asymptotes and the removable discontinuities for the function x squared minus 5x plus 6 over x minus 3. If we set the denominator to 0 and solve for x, we get x equals 3. And plugging in 3 into the function gets us 3 squared minus 5 times 3 plus 6 over 3 minus 3, which gives us 0 over 0, which is indeterminate form. Because we get 0 over 0 when we plug in 3, this must mean a removable discontinuity exists at x equals 3 for the function x squared minus 5x plus 6 over x minus 3. If you look at the graph for this function, you'll notice a removable discontinuity at x equals 3, where the function is undefined. Moving on to example 2, we again have to find the vertical asymptotes and removable discontinuities for the function x squared plus x minus 12 over x squared minus x minus 2. If we set the denominator equal to 0 and factor, we find that the zeros are x equals 2 and x equals negative 1. If we plug in x equals negative 1 to the function, we get negative 1 squared plus negative 1 minus 12 over negative 1 squared minus negative 1 minus 2. Which simplifies to negative 12 over 0. This means a vertical asymptote exists at x equals negative 1. If we were to plug in x equals 2 for the function x squared plus x minus 12 over x squared minus x minus 2, we get 2 squared plus 2 minus 12 over 2 squared minus 2 minus 2, which simplifies to negative 6 over 0. meaning a vertical asymptote exists at x equals 2 for the function. Therefore, for the function x squared plus x minus 12 over x squared minus x minus 2, two vertical asymptotes exist at x equals -1 and x equals 2. If we look at the graph for this function, we noticed the vertical asymptote, which is the dotted line at -1 and at 2. Okay, for our last example, we have to find all vertical asymptotes and removable discontinuities for the function x to the third minus x squared minus 14x plus 24 divided by x squared plus 3x minus 4. If we set the denominator equal to 0, then factor and solve for x, we find that the zeros are x equals -4 and x equals 1. Plugging in x equals -4 into the function, we get -4 to the third minus -4 squared minus 14 times -4 plus 24 all over -4 squared plus 3 times -4 minus 4. Simplifying this gets us 0 over 0, which is indeterminate form, meaning a removable discontinuity exists at x equals -4. At x equals 1, if we plug 1 into the function, we get 1 to the third minus 1 squared minus 14 times 1 plus 24 all over 1 squared plus 3 times 1 minus 4. Simplifying this gives us 10 over 0, which means there's a vertical asymptote that exists at x equals 1 for the function. Therefore, the function has a removable discontinuity at x equals -4 and a vertical asymptote at x equals 1. If we were to graph this function, we'd notice a removable discontinuity at x equals -4, where the function is undefined, and a vertical asymptote at x equals 1, where a dotted vertical line exists. Thanks for watching, and make sure to like and subscribe.